This talk is called The Good News About Killing People. In fact, we changed the title to reflect more accurately what our results are. The new title is The Cautionary News About Killing People and Other Irreversible Acts. I'll explain why this was needed. I mean, partly we would just like to be agreeable people. Susanne, Burri, and I are, we both try our best to be agreeable. But also the result itself is, I think, better described by this name, the Cautionary News Principle. By the way, Susanne Burri herself had a sick baby this morning, so she had to run the baby into the hospital, and she's now not appearing with us. But we'll send her the notes on this and on your questions when she gets back. So I wanted to talk about irreversibility a little bit. Largely, this talk is going to be about making decisions and justifying our choices when we're faced with a choice which is in some sense irreversible. And to give you an example of that, this is one of my first encounters with irreversibility when I was an undergraduate. I had this month when I came back from studying in France, and I didn't have any money yet. I'd gotten a job.
The noise irritates you.
The noise? Sorry, which noise? Sorry, okay, somebody said something about a noise.
I don't hear any noise.
Okay, good. Thanks, Balazs. Yeah, so I came back from a month in France, didn't have any money yet, and a friend kindly allowed me to stay with him for a month. And I got a job, and so I was going to get paid and be able to pay him back, but I couldn't do it until the end of the month. And so I painted him a picture instead, which is what you're looking at here. And he said after he received it for a couple of weeks, "It's such nice flowers. I really like the flowers." And I finally said to him, "What about the face?" And he immediately had this irreversible change in perception that I'm going to give to you now. He saw this. And after this experience, couldn't stop seeing the face. Every time he looked at the painting after that, he only saw the face. And people often have that experience with this thing. It's a curious painting in that way. So this is an example of a choice. I had a choice to tell him or not tell him about the face, and it irreversibly changed his perception. So in this talk, I'm going to talk about choices that involve death in particular. But really, again, all the discussion should be viewed as a comment about a more general kind of choice, where one option is irreversible and the other one is not, in this way. So I'm going to start with a prelude about what it means to choose death or not to choose death in various examples. And then I'll discuss irreversibility in more detail, so you can see what I mean by that. And then finally, I'll present this cautionary news principle that Susanne Burri and I have been working on. I'll give it in an informal way, and then I'll discuss the mathematical model we use to derive it. And that'll take place in this fourth section in the expected utility discussion. So choosing death. Now, I know you're all social distancing at home, so you don't have to think about the coronavirus. But I'm afraid I'm not going to avoid talking about it this time. So since we're talking about choosing death, I wanted to start by going back in time 1 week. So today is Wednesday the 18th. So last Wednesday, the 11th, the World Health Organization announced that the coronavirus is a worldwide pandemic. And so here's a quote from the Director General of the World Health Organization. He says, "Several countries have demonstrated that this virus can be suppressed and controlled. The challenge for many countries who are now dealing with large clusters or community transmission is not whether they can do the same, it's whether they will." So striking words from the World Health Organization, facing many countries who just seems to not be acting after almost 2 months of viral transmission around the world. So the next day, I got on an Excel spreadsheet and started writing down the data for fun to keep track of what's happening. So this is Thursday, 12th March. And I just wrote down the number of deaths on each day in the United Kingdom. And so you see one on the 5th of March. Now this is the total number of deaths. So there was one more on Friday, the 6th of March. So a total of 2 there. It remained at 2 on the 7th, and so on. It starts going up until you see on Thursday, the 12th of March, it was at 10. And if you look carefully at it, you would see that every 2 or 3 days, the number is doubling. The total number is doubling. And if you think that viral growth is exponential growth, as it usually is, once there's an outbreak, you would think these deaths ought to grow exponentially as well. And if you wanted to get a fix on how many people are infected, this is just very basic, sort of back of the envelope calculations without too much sophistication here. You might recognize that the death rate is 1% at least for this virus. And so to know the number of cases, you can multiply by 100 and know that by March 12th, we've got about 1,000 cases. Now, this is the data that I wrote down. I'm using the sort of growth factor. So I'm really just, I figured that the number of deaths is all that can really be trusted here, since we're not testing particularly widely in the UK. But when someone dies, it's a public record and it's kept careful track of. And so I used the death rates to sort of calculate a growth factor. And the average growth factor at this stage was 1.42. And you can just, keep multiplying times 1.42 on this total number of confirmed deaths. And you would find that after 6 days, you should expect there to be 60 deaths. So this was sort of my prediction, sad one that I didn't wish to make. And then there was a UK response on the same day. So in numerous different outlets, through numerous different people, the UK government suggested that their strategy would be one of herd immunity. And this is one of the central science advisors, David Halpern, speaking here. He says, you want to protect those at-risk groups so that they basically don't catch the disease. And by the time they come out of their cocooning, herd immunity has been achieved in the rest of the population so that further transmission won't happen. But essentially, part of the strategy was for people to catch the disease. And so you didn't see a lot of the suppression measures that you saw in other countries, including banning mass gatherings. Another example, the next day in this very controversial Guardian interview with the chief science advisor to the government, Patrick Vallance, he said, if you suppress something very, very hard, and when you release it, those measures, when you release those measures, it bounces back, and it bounces back at the wrong time. So what you see in this approach is a concern about the future, and it's a decision to act now in a way that might look like it's not doing the best for all people right now, because it's allowing a lot of people to catch the virus. But their claim is that in this sort of uncertain future, when we do a cost-benefit analysis, we get the best results. This was sort of the government argument up through the end of last week and continuing into the beginning of this. So, of course, on Tuesday, yesterday, we had seen a lot of growth. And remarkably, when I checked last night, the total deaths in the UK were exactly 60, like my back of the envelope calculation suggests. And this was the data that I was using. And so you can see here, I haven't checked this afternoon what the current numbers are, but as of this morning, there were 71 total deaths reported. And you can do a similar thing and project forward using the average growth rate. It's now 1.45, so pretty stable. And you find that in 6 more days, there should be a total of 673 deaths. Really sad. Now, by today, 18th of March, the government's herd immunity language has been dropped. This was sort of poor language from the outset. But you can see that a lot of their strategy appears to be similar in that mass gatherings are still allowed. Bars and restaurants, as I was cycling rapidly to Dr. Nguyen's house for this lecture, I saw that the bars or restaurants are still full. Schools are still open. and testing is only for the hospitalized in the United Kingdom. Now, the consequences of an unsuppressed virus that is just allowed to rip straight through the population in the UK are an infection rate of about 80%. That's what's expected. So for a country of 66 million, that's 53 million infections. And if the death rate remains 1%, then that would be a total of 530,000 deaths. So the strategy has a clear consequence of deaths if left unmitigated like this. Now, the way I'd like to construe this choice, it's a difficult choice, of course, that the government faces and that all countries face right now. The way I'd like to construe it is as between two sorts of options, one of which is reversible and the other which is irreversible. Now, the reversible choice, in a sense, it is reversible. It is the one where you choose to suppress the spread of the virus as radically as you can. You ban mass gatherings. You ask all people to social distance, not just infected people or people with a cough or fever. And the irreversible option is the one where you allow it to continue spreading. Irreversible because once the cat's out of the bag, it will, it's much harder to contain. It will continue spreading. Reversible because you can always relax those social distancing measures, and you could get the sort of scenario that Valence predicted, that you would see the virus bouncing back again as soon as you relaxed your suppression measures. But one of the main features of these options that I'm also interested in is uncertainty. So in both of these two choices, the future is simply uncertain. We don't know if our colleagues in Seattle who are doing human testing already on a vaccine might be successful, and if in two or 3 months' time a vaccine might be available. We don't know if the virus becomes suppressed by weather changes over the course of the summer. We just don't know a lot of things. And that uncertainty is crucial. It means that we at best have probabilities associated with the benefits that we predict and the losses that we predict at future times. So this is a sort of choice set I'm going to be interested in. Remarkable that it's, and sad really that it's facing us in such a clear way right now. But this sort of thing happens often. So let me be more brief now and just mention a couple of other examples of this sort of choice set that we often face. You have a option to begin to mitigate climate changes caused by human industrial effects. And the other option is to wait and do nothing. Now, acting to slow climate change is in a sense reversible. And that's because you could just go back to your dirty carbon producing ways and set things back on course to the way they are now. But inaction is in a certain sense irreversible, that once certain climate changes begin to happen, there's no going back. And again, there is a great deal of uncertainty associated with these two choices. So this is the sort of case that Susanne and I are interested in. Another example is irreversible surgeries versus waiting. You may wish to have a dangerous surgery that will change your life in some way. You may wish to have a change associated with your choice of gender, and that may be irreversible. And then in each of the scenarios I'd like to consider, there's another option where you just wait, and you could always change your mind later and decide to get the surgery at a later date. Another example is a death penalty. You've got a person sitting on death row. You could decide to execute now, or you could move them to a life sentence. Now, there's a sense in which you lose opportunity by sitting in your jail cell, of course, but there is a greater loss of opportunity when you die. And so and of course, there's a sense in which putting someone to death is irreversible in a way that allowing them to live is not. You could always change your mind later about that choice to allow them to live. And finally, the sort of Camus-driven example and the Greek Sisyphus driven example, we're all pushing that rock up the hill, aren't we? And trying to get the papers marked and our tasks completed. And sometimes it just feels like pushing that rock up the hill just for it to fall back down again, but you keep on pushing. And Camus asked, what really keeps us from just letting it go? And he sort of called this the absurdity of life, the fact that we do just keep pushing that rock up the hill without any apparent external meaning. And his conclusion, of course, was that we should really laugh and at ourselves and at the plight that we're in, at the absurdity of life, and continue pushing. But from our perspective, this is again an example of a choice set where one option is irreversible, to let go, and the other option is reversible. You can keep pushing and decide later to let go if you wish. Now, so these are some background examples. Let me briefly comment on the main approach that you find in the moral philosophy literature on these sorts of examples. And that is the rights-based approach. Now, on a typical approach to evaluating whether or not to put someone to death, whether or not to kill someone, whether or not to allow death, on a rights-based approach, one begins with the assumption that death is gravely wrong and just should be avoided in absolutely the majority of cases. And indeed, that you have a right to life, which shouldn't be infringed upon except in these particularly exceptional cases. And then part of the interesting study is to investigate those exceptions. Under what circumstances does a person forfeit their right to life, if any? Under what circumstances can a person waive their right to life, if any? And these are the sort of broad frameworks that you find in the seminal works of Judith Jarvis Thompson in 1990 and Jeff McMahon in 2002. And this is the typical approach to these sorts of questions. But curiously, a consequentialist approach is rarely studied for these sorts of questions. And our best guess, meaning Susanne and my best guess, is that perhaps it's viewed as just a little too easy. That when you're facing a choice of death versus life or some similar irreversible act, what the consequentialist does is rather straightforward. And let's first consider the example when there's certainty as to the outcomes of your actions. In the first instance, you could say an act is justified if and only if a morally better outcome is produced by your action than would be produced if you didn't act in that way. This again is assuming that the outcome of your action is certain. There's no question about what will happen if you act in this or that way. So it does seem straightforward, not much to discuss perhaps. You just have to figure out what's morally better than what. But a more interesting example, of course, as usual, is when there is uncertainty about the future and uncertainty about your actions. And in that sort of situation, you have a spread of different approaches within consequentialism, and I'm not going to discuss very many of them. I'd actually like to focus on just one, the utilitarian approach. But just to set out a couple of different approaches, the utilitarian or Bayesian or expected utility maximizer will say, just maximize expected utility. Again, it's quite simple. You determine the probabilities associated with each possible outcome. You determine the values and costs associated with those outcomes. And then you sum the probability weighted values of each of these outcomes. And that gives you your expected utility. And now you do the same for each of the choices that you face, and you choose the option with the maximum expected utility. There are other consequentialist approaches like maximin or minimax, depending how you put it, where you would do something like just maximize the minimum cost amongst the various options available to you. But essentially, it's meant to be a straightforward calculation and not one we need to spend a lot of time worrying about. There's not a subtle discussion of which rights conflict with which and how we deal with those sorts of situations. But Susanne and I disagree. We think actually there's a great deal of certainty and there's a great deal of interest in exactly these sorts of questions, and we want to poke around a little bit and see what we find. So to show how this can get a little interesting, Susanne has an example that she calls the two lives from a forthcoming paper. She says, consider two lives with equally good expected outcomes. You've got life 1 and life 2. So when you sum, sum the value of each of these lives and the cost of each of these lives, and by all measures, they just come out the same. But one of them in the diagram is meant to indicate the person lives a lot longer. And the other one, the person lives a lot less. And you could even example that this is one person who happens to have this interesting knowledge about the future, that by continuing to, they could live and then choose to die at some midpoint in their life, or they could continue living a much longer time, but the total value is going to be the same. Not much changes. And in that kind of situation, you see a split in how the different accounts approach this problem. A rights-based account would often say, choose more life. You have a right to life. You shouldn't be asked, it would be a special circumstance when you're asked to waive your right to life or when you forfeit your right to life. And so you have an opportunity, at least with this sort of approach, to choose more life. But the utilitarian is usually thought to say, well, just choose either one. There's not a morally better outcome by choosing one or the other, so it's just the same. And Susanne and I think that this sort of question is in fact ill-posed, that there's an aspect of this discussion which has been missed, and that the choices that you face in exactly this kind of example have a quality that is irreversibility, a choice that you can't take back, which has not been appropriately incorporated into the decision problem. So our approach says you really need to weigh the irreversibility in a special way. And we'd like to talk about what that way is. Once you do that, you can adopt an approach which is broadly utilitarian. So we are not so much designing a totally new consequentialist decision rule here. But we are pointing out that irreversibility plays a special role in these judgments, which is typically ignored. And we'll show you what that role is and why it happens, and we'll do a little calculation in the context of utilitarian thinking to help get to that. So that was the background discussion on choices between an irreversible act and a reversible act, like death as compared to life in a situation of uncertainty, and where we're asking really when is an act that leads to death justified? And in particular, we would like to ask this question from a consequentialist and a utilitarian perspective. So now next phase is to talk about this concept I've said several times now, irreversibility. I'm going to give you a sort of brief overview of this term, which is of philosophical interest in its own right, very familiar to philosophers of science and philosophers of physics. But I think it may be useful more broadly in philosophy. And then we'll zero in on its implications for decision-making and choice. So irreversibility in time is a really modern idea by my lights. There's various ways of measuring this. But if you do, you can go on Google Ngram Viewer. In the slides, by the way, these links are live. So if you go through the slides in your browser, you can click any links that you find here. So if some of the sources are linked here, you can find them that way. So Google Ngram Viewer lets you count the number of times that a word or phrase is found in a book in Google's scanning index of books on Google Books. And so you can use this tool to get again, not a super careful, but a back of the envelope fix on the usage of a phrase or word. And people didn't often talk about this concept that is sometimes called the arrow of time, that as time passes, it does so in a way which is directed and irreversible. It never turns around and goes the other way. And on various ways of putting this, you find that it lacked discussion until about 1800, when people started developing things like engines. So that first little blurb there is Carnot, Sadi Carnot, who wrote a book called The Motive Power of Fire in French about an engine. And if you think about what an engine has to do to work, you have an explosion, which causes a piston to get pushed out of a cylinder. And in order to, that's sort of turning a wheel, that's kinetic energy. And to make it keep turning, like when it's a car or a train, you need to reverse the process in a certain sense. You need to go back to where you started and allow the explosion to happen again. So Carnot was centrally interested in the concept of reversible as compared to irreversible processes. Some further physicists that thought about this, Boltzmann in the context of statistical physics and Eddington in his discussion of the arrow of time. And then it was discovered in the 1950s and 60s that there's this extraordinary symmetry violation associated with a preferred direction of time, an arrow of time in fundamental physics called neutral kaon decay. And at any rate, philosophers picked up and started talking about it after this. But it's a quite new idea associated with the development of modern science and industry. And we're going to apply it now in a quite general way. So irreversibility in time, the direction of time. Irreversible physics is associated with things that increase in entropy, like a burning cigarette or breaking glass. These are often said to be associated with initial conditions rather than a law, but roughly what you have is a phenomenon that happens in one direction of time, and it doesn't reverse. You don't have a cigarette unburning, meaning all of the discharged particles fly back in exactly the right way to become lodged in the cigarette and lengthen it so that you get an unsmoked cigarette at the end of this process. That just doesn't happen. So this is an irreversible process. In the weak sector, there are certain sorts of decays which happen in a way that cannot be reversed. So when a neutral kaon decays into two pions with some probability, the reverse process isn't possible. The two pions don't decay into a neutral kaon with the same probability. You have irreversible chemical reactions, like when banana interacts with oxygen and turns brown. Various instances of irreversible biology. You have in selection phenomena, the wheel sort of having the bits of the fan in between the spokes fading away due to natural and sexual selection. And this process doesn't reverse. It happens in one direction in time. It doesn't go, those don't come back again, those lost birds. And of course, in the development of life, you don't ever see a process like this, where the butterfly sort of unfolds back into a cocoon and then becomes a caterpillar again. You only see this happening in one way. These are common examples of irreversibility in science. And of course, there is the irreversible flow of time. Aristotle referred to it as prosteron and heusteron, associated with later and earlier than phenomena. But today it's often viewed as this flow which happens in one direction and which never goes back again. Once you've passed through a moment in time, you don't ever go back. Pache, our colleagues who study things like time travel, like Balazs Genish in the audience. Now, our interest today is in an irreversible choice, a decision that you can't take back, where by take back, I mean an opportunity to consider that same choice set again at a later time. So this is what distinguishes the choice to wait before you do that surgery that's irreversible, or do it now. If you wait, in many cases, you will have an opportunity to consider the same choice again. If you don't wait and do it now, then you won't face that same choice set again. You can't undo what has been done. It's a Lady Macbeth type choice. So here again is the sort of choice that we're interested in. Option 1, reversible. Option 2, irreversible. We have some information about what the value is now, what the cost is now, but the future is uncertain. Now, how do we weigh decisions with this special irreversibility in play? The principle that Susanne and I would like to propose is called a Cautionary News Principle. And I'll first say what I mean by cautionary news. So it finds its origin in the work of Ben Bernanke, of chairman of the Fed fame in the United States Federal Reserve. While at Princeton, he wrote an article now known as the Bad News Principle, which was about investment, which is irreversible. And the idea was, you're going to level a sequoia forest, or you're going to invest in an energy supply system, which once you've paid for it, it can only be used for that. So you can't reverse your investment here if you decide later that you don't want to continue with that investment, or that it's a bad investment. So for Bernanke, there was two interesting kinds of news that could come in the future. Good news would mean you made the right investment. Good for you. Bad news would mean you made the bad investment. And if it's an irreversible investment, then bad news is really bad. You can't take it back. So now, and I've sort of given you I think I haven't got a link in here, but you've got the title of the paper here, Irreversibility, Uncertainty, and Cyclic Investment, I think, from 1982. And the central idea is that there is uncertain future information and two kinds of information that could come in. Susanne and I would like to point out that more generally, that information can be of one of two kinds. I think good and bad is not a helpful way to put it. There's a sharper way to put it. And that is, one kind of information is confirmatory. It confirms that you did well in acting irreversibly. So it is a reason to act irreversibly. And another kind of information is cautionary. It says, hold on, wait, warning, there may be reason not to make this investment. The energy market could tank and you didn't want to make that investment in the first place. And the key about both is that they are uncertain. So there is some possible good news that you could get about any of the acts we've talked about so far, but let me just take Corona. Possible good news is something like a vaccine next week. Possible bad news is it is possible to get the virus twice. You get it once and you don't build immunity, so you get it again, and the whole government strategy falls apart. So there's possible good news and possible bad news, both of which are uncertain. And again, I think now Bernanke's way of speaking is, it's how he spoke originally. It can be powerful, but I think more accurate is to say confirmatory, confirms your irreversible act, or cautionary, cautions you not to act. So let me take these ideas and we'll generalize them into this cautionary news principle. And I'll argue for this in a moment, but let me just say the principle. It says, when comparing an irreversible decision like death to a reversible one like life, possible future cautionary news is relevant, but possible future confirmatory news is not. So that means any possibility that your irreversible act that you're considering doing might be a bad idea, that's extremely relevant to your calculation, even your utilitarian calculation, in a way that possible confirmatory news that you made the right decision to do this irreversible act is simply not relevant. So I'm going to give you a rough argument for why this is, and then I'll talk a little more technically about it. So here again is the choice set, a reversible option as compared to an irreversible one. Life now as compared to death now, with the future uncertain. And consider again our two lives. I'd like to consider two different cases here. Now remember, there's an irreversibility in the life choice and the death choice. And our claim is that irreversibility in the choices, it's an asymmetry really between the choices. It introduces an asymmetry between the kinds of information, confirmatory and cautionary. So consider first the life option. Suppose we choose that. And you could get two kinds of news. You could get good news, you could get cautionary news, and you could get confirmatory news. So future confirmatory news would say, well, you could have made the irreversible act here. You could have chosen to die, but you have an opportunity now to change your mind and allow death. But the point is, it's not a big deal on this choice because, well, you can change your mind. If you get news that says death was better, you have an opportunity to change your mind. Similarly, with future cautionary news, it says, oops, if I got this backwards, future confirmatory news, you can still change your mind. Future cautionary news, you made the right choice. If you choose yes, so you chose the option not to kill, let's say. You're considering killing a person. If you've got news that says you should have killed, you can always do it now. If you got news that says you shouldn't kill, then great, you made the right choice. So in both cases, you're sort of happy. Either you get news that is telling you good, it was right not to kill, or you have news that says, well, you ought to change your mind, and then you can do it. But if you choose the death option, the irreversible option, this asymmetry emerges. You might get confirmatory news in the future that says you made the right choice there, but you also might get future cautionary news that says it was wrong to make that choice of death. Things might have gotten better. And then this wrong choice was irreversibly made, and there's no going back. So there is a difference between confirmatory and cautionary news that comes exactly because these two options are asymmetric, in that one is irreversible and the other is reversible. And the central lesson is that possible cautionary news matters more in a way that possible confirmatory news doesn't. So we formulate this more precisely, and I'm almost done here now, with an expected utility analysis. And the basic way to understand what we do, which is different from the typical calculation, is, if you imagine your expected utility analysis consists of this great branching tree with many different possible outcomes in the future. And there's a probability assigned to each possible outcome, and there's a value and cost assigned to each possible outcome. We think that irreversibility is not being correctly weighed in a typical tree. Bernanke's got it right, and we can describe a toy model that sort of generalizes what Bernanke does by basically pairing the tree. You have to cut some of those branches, because in some cases you will have a repeated choice. You'll get a reversible choice, which means you can consider your same choice set again. You go from a branching point up to another branching point. But if your choice is irreversible, you take an irreversible option, you no longer have a branch. You must prune that branch. And when you carry out this pruning at the level of your expected utility calculation, you find a cautionary news principle, which says something like what I've just said. And I'll tell you in more detail now. So the quantitative analysis can be made really, really simple to just get rid of all the irrelevant details in this way. We look at a 2-time model. You've got your initial time t0, and you've got a later time t1. And this is not a serious idealization in the model, in that you can consider a countable set of discrete times, or even a continuum of discrete times, or rather a continuum of times, and achieve a very similar analysis here. So nothing in this discussion hinges on the fact that I'm using just 2 times, but it makes it a lot easier to see what's happening. And at the initial time, there will be some initial value of, say, continued life. And let's just make it concrete. Your alternative is death. And then you've got a cost of acting, say, to allow death. And, sort of the simple cost-benefit analysis would just weigh those 2 variables. But of course, this would radically discount the future. It matters what the future values are, and that will require us to look at reversibility and irreversibility in our choices. So 2 different kinds of news here, cautionary news and confirmatory news. They're both construed as real numbers greater than 0. They're both positive numbers, strictly. And it's sort of representing the quantity of cautionary news as compared to the quantity of confirmatory news. And to evaluate the value of continued life at the second time, at the later time, t1, we just do a very simple thing. We're trying to, this is sort of, and now there's a number of functions you could use for this, but what we basically want to say is that if you get cautionary news, and that could be news that says, for example, don't kill, then let's see, or if I got this right forwards or backwards, let's see, confirmatory news. You see, the difficulty we had is that when we began this, we were calling this a good news principle, opposite of Bernanke's bad news principle. And we since generalized this to just be about cautionary and confirmatory news. So I do get mixed, I apologize for getting mixed up about which one's which in our examples. So I'm saying confirmatory now. In effect, what I want to say is if you choose an option with where, I've got a concrete case like the choice to die now, or to continue living, and then at time t1 to face the choice again whether to continue living or to die. And in between, I could get either cautionary news or confirmatory news. Now, the value of continued living at time t1 is greater if I've gotten cautionary news, confirmatory news. It just sort of increases, and it goes down if I've got it goes up if I've got confirmatory news, and it goes down if I've got cautionary news. And I make these the only options. So I've got probability p for one and probability 1 minus p for the other. And the sort of acts that I'm considering are ones where there is some cost to my action. So if I act now, I must sort of subtract the cost from my calculation. If I choose to wait, then there's no cost and no value to my action either. But now at this later time, there could be value to my action, but that now there will be a cost. And how does that updated value change at the later time? Well, it changes in this way here. So yes, you could imagine I got good news like there's greater value to your life, caution, don't pull the trigger, or there's less value to your life, and so you don't have that warrant, you have confirmatory news. We also discount the future. The idea there is just as in interest in a bank loan, when you're considering value at some moment in the future, that quantity of good is not the same as it is to have received it now. And there is some literature and discussion about whether this sort of discounting ought to be applied in moral philosophy. It gives a very nice, we're choosing the general way of discussing this, where we do include discounting, and you can remove it if you like. But so we have a discount factor, and we make a couple of assumptions in our decision model. The first is that the reverse, we've got two choices in our choice set. This reversible act where we wait, and that means we get to face the decision again at a later time, or the irreversible act where we act now, and then we don't get to choose again. And the reversible act is a choice at some time t, only if the irreversible act was not chosen at an earlier time. So that is what it means to be reversible in this context. And then apart from that, we just assume a utilitarian calculation in the sense of the choice of highest expectation value will be the one selected. And we combine these two things and we get something hardly deserving of the name theorem. It's a very simple calculation, which is available in our draft on request. And this is a sort of formal expression of the cautionary news principle. So it says, we'll have an inequality, and the choice to act irreversibly should be selected if and only if the equality is true. And when you look at this equality, you will see the cautionary news principle in it if you think about what these variables mean. So we've got our initial value, V0. We've got the cost of acting. We've got a discount factor, D. We have a probability, and we have the quantity of cautionary news, not the quantity of confirmatory news. It simply drops out of the inequality. Terms cancel and it goes away. So formally speaking, on this analysis, really the only thing that matters is cautionary news, and confirmatory news supporting that, yes, you should allow death, that irreversible act, as possible news in the future, is simply irrelevant. the news that's relevant is the cautionary news, the kind of thing that says, wait, maybe you ought not to carry out that irreversible act. And now again, our aim here is to sort of present this principle and its context. One could further go through and apply this to many of the cases I discussed at the outset, examples like the coronavirus. When one is wondering, whether or not there could be possible confirmatory news that this choice to allow more death is the right choice, the quantity of that kind of news is irrelevant to this sort of irreversible decision. What is relevant is cautionary news, the possibility that there could be news in the future which advises you not to allow death. And news like the discovery of a vaccine would be of that very kind. So that sort of possibility is what's relevant. So again, theorem gloss, the quantity of future cautionary news, i.e. news supporting not acting, is relevant for the decision to act irreversibly, but not the quantity of news supporting acting. Now, if you think about what the different variables do, you can see a few sort of appropriate things. Suppose you have very low probability of confirmatory news or supporting news. So that's 1 minus p close to 0. So then it goes from being a problem of uncertainty to a problem of certainty. And this then reverses to an ordinary cost-benefit analysis, as one would expect, so a reasonable thing. You can do things like let the cost get very, very low. The cost of acting becomes very, very low. So you're considering some surgery and there's just very few complications, very low cost associated with this choice. Then you will get a situation where the right term gets very close to 0. And so for almost any positive initial value for your choice, this inequality will be satisfied. And so this means you should always choose to act. And that also makes sense. Of course, we would like to emphasize this hesitation that it's in general hard, and we should be very wary when we assign a real number to the value of a human life or the lives of the British public, or to our bodies when we carry out a life-changing surgery, etc. Very, very hard to use utilitarianism in a situation like this. But this analysis is a start. We have played around with some other analyses like maximin and find some very similar results. Our decision frameworks can be explored and compared in precise terms. We think that's an advantage. You can say something about the spirit of this argument without formal analysis, just thinking about this, how this asymmetry in our choices bears on an asymmetry in possible future information. And finally, we can just do better than existing arguments. An overly simplified cost-benefit analysis pales in comparison to this. This is at least better than some of what we have so far. And that's all we'd like to say today. So thank you for listening.